All right, the nature of force. So a common misconception is that any object that is set in motion will slow down on its own. Here's the fact. A force is needed to change an object's state of motion. So let's say a soccer ball sits at rest. You come along and kick it, sending it flying across the field. It eventually slows to a stop. You applied a force to start it moving, and then it stopped all on its own, right? No. Forces cause all changes in motion. Just as you applied a force to the ball to speed it up from rest, the ground applied a force to slow it down to a stop. If the ground didn't apply a force to the ball, it would keep rolling forever without slowing down or stopping. So, give us an example of a force you apply to slow something down. And where might it be possible to kick a soccer ball and have it never slow down? All right, so how are forces described? In science, the word force has a simple and specific meaning. A force is a push or a pull. When one object pushes or pulls another object, the first object exerts a force on the second object. You exert a force on a computer key when you push it. You also exert a force on a chair when you pull it away from a table. Like velocity and acceleration, a force is described by its strength and by the direction in which it acts. Pushing to the left is a different force from pushing to the right. The direction and strength of a force can be represented by an arrow. The arrow points in the direction of the force as shown in Figure 1. The length of the arrow tells you the strength of the force. The longer the arrow, the greater the force. The strength of a force is measured in the standard unit called the Newton, after scientist Sir Isaac Newton. So for example, in this one, this guy on the left is pulling him in for a hug. So the force is him being pulled that way. All right, describing forces. Forces act on you whenever your motion changes. In the photos at the right, two men are celebrating an Olympic victory. Forces cause them to pull each other in for a hug, lean over, and fall into the pool. So, in the box within each photo, draw an arrow that represents the force acting on the person on the right. The first one is done as an example. Okay, so this one's done an example. This guy is being pulled in by this guy. So the force is to the left. Now you need to show the force that's on this guy in this box and now. So always looking at the guy that is on the right. All right, net force. The change in motion of an object is determined by the net force acting on the object. So here, you're going to calculate and draw an arrow for the net force for each situation in the boxes below. How do you do that? We're about to find out. So how do forces affect motion? Often, more than one force acts on an object at the same time. The combination of all the forces on an object is called the net force. The net force determines if and how an object will accelerate. So when you're calculating net force, you can find the net force on an object by adding together the strengths of all the individual forces acting on that object. So look at Figure 2A. The big dog pushes on the box with the force of 16 newtons to the right. The small dog pushes on the box with the force of 10 newtons to the right. The net force on the box is the sum of these forces. The box will accelerate to the right. In this situation, there is a non-zero net force. So a non-zero net force causes a change in the object's motion. This means that either the object's speed or direction changes. Okay, so this is the figure. The bigger dog is pushing to the right with 16 newtons, the smaller dog 10 newtons, so that is going to make that box go to the right, and we would add the sum of those two arrows. We would add those two arrows and get the sum, and that would be our total force. All right, in Figure 2B, the big dog pushes with a force of 20 newtons. The small dog still pushes with a force of 10 newtons, but now they're pushing against each other. When forces on an object act in opposite directions, the strength of the net force is found by subtracting the strength of the smaller force from the strength of the larger force. You can still think of this as adding the forces together if you think of all forces that act to the right as positive forces and all forces that act to the left as negative forces. The box will accelerate to the right. When forces act in opposite directions, the net force is in the same direction as the larger force. So if you look over here, you're going to use the information that I just read to determine the net force of these two force arrows. All right, balanced and unbalanced forces. In both figures 2A and 2B, a net force causes the box to move. When a net force acts on an object, the forces are said to be unbalanced forces. Unbalanced forces acting on an object will change the object's acceleration. Equal forces acting on an object in opposite directions are called balanced forces. Balanced forces, such as those shown in Figure 2C, do not change an object's motion. So if you have equal forces that are pushing in opposite directions, the object will stay in the same place. Okay? All right, so apply that to, you pull on your dog's leash to the right with a 12 Newton force. Your dog pulls to the left with a 6 Newton force. Sketch this situation, including labeled force arrows below. Then calculate the net force on the leash. Label it in this same picture that you drew. All right, so 1A, calculate. You push on a desk with the force of 120 newtons to the right. Your friend pushes on the same desk with the force of 90 newtons to the left. What is the net force on the desk? In what direction will the desk move? All right, predict. So your friend increases her force on the desk by 30 newtons. She doesn't change the direction of her push. What happens to the net force on the desk? Will the desk accelerate? All right, so how are force, motion, and energy related? You know that changes in motion result from unbalanced forces, but how can you apply a force that can unbalance other forces? In order to apply a force that changes an object's motion, energy must be used. The games shown in Figure 3 are examples of energy being used to create forces that change an object's motion. You may recall that energy is the ability to cause change or do work. You may also remember that two basic types of energy are potential energy and kinetic energy. Okay? So the games in Figure 3, dunking booths, races, and milk bottle tosses are games that involve energy, force, and motion. Alrighty, so you're gonna answer the questions in the boxes. Potential energy. Energy that results from the position of an object is called potential energy. Potential energy is stored energy. A book on a shelf has potential energy. If it falls off the shelf, the stored energy will be released. So you're gonna answer this. Circle the person who has potential energy. Explain what will happen when the stored energy is released. So in this picture, you have somebody in a dunking booth, and you have people throwing the ball to try and knock the kid down off the dunk booth. Okay, so you want to circle the person who has potential energy. All right, kinetic energy. Energy that results from the motion of an object is called kinetic energy. A bird in flight, a dancer in motion, and a boat speeding through the water all have kinetic energy. Kinetic energy can change the motion of another object. Okay, so draw an arrow on the picture to show the direction of the dog's motion. Describe the kinetic energy in the picture. So on this little dog, you need to draw an arrow that describes his motion. All right, and then the last one is energy transformation. So potential energy can transform or change to kinetic energy, and kinetic energy can transform to potential energy. A toy car rolls down a ramp with increasing speed as its potential energy is transformed to kinetic energy. The car slows down, moving up a ramp, as its kinetic energy is transformed to potential energy. All right, so circle the objects providing force for an energy transformation. The energy in the milk bottles is transforming from blank energy to blank energy. So circle the object that is providing the force, and then tell me what energy transformation is happening within the bottles. All right, and assess your understanding. Compare and contrast what is the difference between potential and kinetic energy. All right, and then when you stretch a rubber band, what form of energy are you giving it?